welcome everyone to another episode of Vega Insights. I'm Luke Bideaux, the president and CEO of Vega Imaging Informatics. And today we're excited to have the Stanford Imaging Enterprise team with us. And they're going to talk about their transition from one digital pathology solution to another for archiving. With us today, we have Heather, Nikki, Chris, and Godwin. And I'm going to turn it over to Heather to kick this off. Heather, why don't you just tell us a little bit about the scope of this change that you guys did?
Absolutely. So about 3 years ago, if not a little bit over that, Stanford realized that we were going to grow out our existing digital pathology platform. So we took on RFP or RFI, then RFP processes in order to see what we would want to do in order to transition to a more enterprise structured digital pathology platform. So we undertook multiple different changes during this multi-year process that led us to moving from our original digital pathology system over to our new platform within our Sectra environment. So we took on quite a few milestones that I guess we'll go over today and walk you guys through all of the adventures that we had over the past couple of years.
Yeah, that's great. So I'm interested to hear, before we get into the project, what were some of the drivers for the change? Were there certain things that were happening with the old system that, you didn't like, or, was it coming to end of life? Godwin, could you speak to that?
Yes, of course. Thank you. So we inherit this pathology from a different team. They are not specialized in imaging like our team does. So this is around the COVID pandemic era that that team who was original responsible for this pathology systems decided to handle to more specialized team like us, the imaging enterprise team. So we took over this with a lot of infrastructure design flaw at the time. For example, a single server architecture design that handles the entire workflow, which is unthinkable, but that's the way the system designed. The systems went over several upgrades to remediate a lot of backend Microsoft systems that keep crashing, sending alerts with the high memory utilizations, all that. And then the version also encountered an issue where we have, I believe, 8 or 9 different Philips scanners, but the version that we had can only allow certain concurrent session. So that was a lot of discovery along the way, and that seriously impact our pathologists, definitely impact the patient care. And just not because the Philips IMS is having problem, their scanner also suffer a lot of issues as well. So the combination of both the server, which is unstable, that require constant service restart, also addressing from the HL7 end, and the database structures, we have no idea what it is, but we were told that the database structure is not suitable for our institutions where we have maybe up to 100 or 200 slides per case. Philips IMS may be designed for small amount. Like us, we are teaching hospitals, so we do scan a lot of different slides, and that does overwhelm their system.
Mm-hmm.
So there's a counterpoint that operations cannot handle it and decide to move on.
Okay, so and this whole digital pathology field, it's new for a lot of imaging informatics professionals, and I think a lot of organizations around the U.S. They're not even digital yet. And here you guys are, you're moving on to your second digital pathology archive solution, which is very impressive. And I think, Stanford should be proud of the innovative work that they've done in digital pathology. And it's just impressive to me that how far along you are with it compared to the rest of the US. Just so I'm understanding clearly here. So what I'm hearing is, you were sort of outgrowing your old system. The system was having a number of challenges with it and issues. And so it was time to make a change. But also, in addition to the archive challenges, you were having some issues with the scanners themselves. So for some of some of us listening that aren't that familiar with digital pathology, Heather, would you be able to explain a little bit about those scanners, how they work, and maybe some of the differences between some of the older models you were having issues with and some of the newer ones you transitioned to?
Absolutely. So our scanners were old. I'll definitely preface that. They were originals from 2019, 2000. They had gone through a lot of iteration and a lot of work by Philips on that. So Philips definitely maintained them as best as they could. But technology has grown, right? Over 5 years. We needed to be able to acquire Z stacking images within our digital platform and take on a lot of more service lines. Stanford does quite a bit of consultations also within our business, and so we needed to make sure that our labels, because the pathology crews will let you know that the labels are very important on the slides, and so we needed to make sure that the scanners that we grew into or that we did go with would cover consultations, consultation changes with those labels to standardize to what we needed in order to ingest those. We also wanted to make sure that we were, by no means are any of us pathology experts on this team, but we definitely needed to make sure we could grow our business here, or the operations team could grow the business to have all sorts of different type of stains included and grow further than what Philips was able to do with the version of scanner that we were on.
So yeah, let me try to make sure I get this. So my understanding with digital pathology, you got the tissue and you got it on the slide, and now you're going to put it into this acquisition device to basically take a picture of it and create a digital image. And then there are annotations or some sort of comments that are made about it. And so are those annotations and comments put into the information system, or are they actually like written or somehow put onto the digital images themselves? How does that work?
Nikki, you want to go ahead and take that one?
Yeah, sure. So the markups, the annotations, it is acquired at the point of read during, in the information system. Measurements, typical things you would expect. There's obviously specific tools that pathologists will use in their readouts of digital slides, but yeah, it's all there, and then it's stored again, in the system, just as we're used to with radiology and the annotations that come
Hmm.
along with that.
So I would assume the platform to create the annotations and store them and view them, when you compare different platforms, like your old platform to your new one, I'm assuming the new one just has better tools to create those, organize them, display them, and so forth. Is that what you found?
Yeah, similar tools. There were some differences that were kind of like for like, or things that the pathologists had to get used to. But I think that the amount of tools that they use is a lot less in an IMS than like a radiologist uses to do all the additional things that they might do for different specialties. So I think in all the different systems that we evaluated, the tool sets were all very similar.
Okay. All right. So, yeah, I'm curious, Nikki, then. So, when Stanford decided to do this change and they made the decision they wanted to look for something new, what sort of market evaluation process did you do? Did you do some sort of RFP? Was there demos involved, pilots? Could you speak to that?
All of the above. There's a lot of very, very smart people that work for Stanford Pathology, and there were a lot of opinions about the type of system they wanted to move to. So there was initial RFIs and then narrowed down, obviously, to a handful of systems that we did have the vendors come in and do demos on site. We ensured that we had our data available to, have real world interaction with what was going on with the systems. A number of our pathologists were engaged. We had a steering committee that worked with us as through this whole system decision making process. And then in the end, obviously, when we had narrowed down to a certain number of vendors, we did an RFP process. which we extensively went through all of the answers, comparing things, assessing between all the different participants of the steering committee, all the way up from, infrastructure technology, all the way down to the nuts and bolts of just what we were talking about, the tools that they're using. Do they like the tools? What can they do? What do they want for the future? And and then obviously it came down to our final decision based on a number of factors. It was, top to bottom, the whole process.
Yeah, it sounds, there's a lot of similarities here with radiology, with PACS. Basically, some of the processes I'm hearing, I've been a part of and I've seen on the radiology PACS side. So that's encouraging, I think, for an imaging informatics professional that has experience with PACS transition. Now you're looking to do some kind of digital pathology transition or implementation. There's a lot of similarities, would you agree, to like on the radiology side? But I'm sure, a lot of uniqueness to this and everything. Stanford has certainly created a scenario for imaging informatics professionals to look to for guidance with everything that they've done. And I know Stanford's done numerous presentations and things through SIM and other organizations to sort of explain what they've learned through all this. So, but I'm interested to learn about the project itself. Chris, maybe you can help fill us in here. So, if it's like a PACS transition, I know there's so many different components. You've got hardware to consider, interfaces, the migrations, training, on and on, right? So let's start with the hardware. What sort of hardware changes went into this project?
So one of the things about transitioning to Sectra was that Sectra had a footprint already. And so that footprint consisted of dedicated VM host servers, dedicated VM storage, but dedicated file storage, etc. As the project goes, we didn't really have to even consider additional step of now we need to pull in hardware vendor X, hardware vendor Y, hardware vendor Z. Okay, who do we want to go with for storage? All right, that box checked. Who do we want to do? So we were able to leverage a lot of the existing, that whole array of the VM side of things, the storage side of things, the network side of things. These were all tools that were already available at our disposal with capacity to add what we needed to add into the environment. So that was a plus, if you want to call it that, we were one step ahead of many steps that needed to be completed. But still beyond that, we still needed to kind of design that virtual layer. What was that going to look like? How many servers do we need? What types of servers? What are the specs of those servers need to be? So we did spend a bit of time with, our partner Sectra working through that. We did that in a couple of ways. One way was initially we performed a proof of concept, right? So we took some of everything that had been learned with the RFI, the RFP, the demos, all of these things. We built out a mini environment in our test environment, Sectra test environment. So we added the digital pathology module on top of that. In that case, it was a little bit more of Sectra telling us sort of, hey, you need one of these servers, you need two of these, you need this, that, and the other, because it was at a much smaller scale. But going through that, not only did we start to learn a little bit about the back end, we were able to continue to validate some of the things on the front end, the viewer, the capabilities, and all of these things. So this was another step that allowed us to inch a little bit closer to where we ultimately wanted to get to in building out that hardware spec for production. And as I mentioned, when we got to that phase, we worked with their solution architect and, our team, our infrastructure teams, which, storage, network, SQL, all the way down the Wintel, all the way down the list to essentially come up with a document a design document that represented every single server that we needed to build, what the function of that server was going to be, how much RAM, storage, how many certificates did we need. And that sort of was the blueprint that we sort of moved forward. Once we had that, then we were able to you know, say, okay, hardware, we think we have this design. Do we have the capacity? Yes. Probably maybe one thing that we did expand on existing was storage, right? The storage needs for pathology are very different than any other animal that we
Yeah.
kind of had, previously. But again, we were able to expand and build on existing platforms rather than bringing in an entirely new storage solution itself.
I find it interesting that doing all of this on premise without going to the cloud. So much of what you hear today is in the cloud, and the hardware thing just is sort of transparent now to a lot of facilities. All they need to worry about is the application configuration and the interfaces and everything. Um, it seems as though you've really made a decision to stick with an on-premise type of solution that you guys control and you can configure how you want it and everything. And with digital pathology, the images being so large, the amount of storage required, it seems like it would be so easy from a planning standpoint to go to the cloud because there's just like unlimited storage, right? And you don't have to worry about it. What was it about keeping it on-prem that really attracted you guys to sticking with that model? Does anybody have an opinion on that?
Yeah, so there were a lot of unknowns with the the project, right? This is digital pathology. It's new for many, if not most. And you can even say that we can even say this for the vendor, right? So the vendor they're learning along with us. And the on-prem model is something that we have a lot of familiarity with, not only with this vendor, but obviously for most of our applications at this juncture. So we felt that that was one piece that we could just set aside. Yeah, can we move to the cloud at one point? Sure, that's option is always going to be there, but we could take that variable out. We know that with an on-prem solution, we really shouldn't be talking about bandwidth, latency, all of these things that we could build this solution in the cloud, and then we come upon these problems and it's like, okay, well, how are we going to solve that? So
Yeah.
we could take some of those things and maybe we're kicking the can down the road a little bit, but we have some expertise. We have a number of teams that have great SMEs in each of the areas that we felt that we could leverage those to our benefit if we were to start with the on-prem model.
I think that's a great perspective. I've seen a lot of organizations go, from a legacy PACS to a new PACS in the cloud. And then they have all these issues. And it's like, all these issues have nothing to do with the new PACS vendor itself and the application. It's all the fact that you went to the cloud and you didn't plan for it. You thought you could get away with it without completely overhauling your WAN circuits and preparing for all this traffic that's been going over the internet. And it was just, not considered how big of a change it was going to be to go to the cloud, whether you stuck with the same vendor or changed to a different vendor. So it's a great perspective to think about, maybe we should, if we're on premise now, stay on premise, make the transition to the new vendor solution, and then sometime in the future, if the time is right, we can move to the cloud. That's interesting.
I will add
Yeah.
that that part I touched on earlier, right, where sometimes when you make a transition like this, you're talking about bringing in a whole new hardware stack, and that in and of itself is a point of we do that and bring in this whole new hardware stack. Whereas in our situation, we said anything that we have in place that we can use to help drive ourselves, towards our ultimate goal, we're going to leverage that, right? So we have, whether that's a component we haven't really talked about, in our solution today, we're leveraging DICOM as the file format. This was something that we wanted to drive through. The previous Philips environment was pretty much proprietary, from the file format to the scanner to the IMS. You had to use those pieces together. It was sort of a closed system, if you want to call it that. Whereas what we were trying to move to was something a little bit more open and leverage what we have, right? So we have a DICOM router, and we wanted to take full advantage of that without necessarily having to bring in new hardware, right? And the same for the Sectra environment, the host servers, the storage, like we talked about. So I think take all of those things sort of taken together, kind of created this environment where we said, hey, we feel comfortable if we go this route. Let's give that a try. Let's use the tools we have. Let's use the expertise we have and see how close that can get us to our goals.
Yeah. I'm curious about the integrations. Are there a lot of integrations like with radiology packs? Is it very similar with digital pathology, making a transition like this, moving all those interfaces over? Was that a considerable effort for you, or what's your perspective on that?
Yes, but not in a bad way. So as you would expect, we needed ADTs, orders, results, all of the things that you would commonly expect. But there's a twist, right? Just like a lot of things, there are specifics with digital pathology, right? Yes, ADTs are pretty much standard across the board, depending, for applications. But the way that the orders work are different, and so we've got ORMs, OMLs, and these different things that, the teams had to rally around to make sure that we were getting everything that we needed from our LIS, which in this case is Epic Beaker, down into the packs. And that took quite a bit of dialogue between the different teams, whether it was the Epic, resources, our team, the Sectra team, the pathology team, department, to really, make sure that we don't just put the radiology stamp on it and say, this is what we do in radiology. This should work, right? It's a different world, and being able to leverage the subject matter expertise, especially those coming from the pathology department, to really explain, well, this is what this is, and this is what this means, helps a lot. And then we had the part of like trying to translate that into DICOM, which is on its own trying to kind of come up to speed and into the fold of everything that needed to happen. So there was a lot of dialogue there, not insurmountable, but detailed discussions required to make sure that we were getting everything that we needed to, from upstream to downstream, into Sectra, and then back the other way, because we are, for the most part, PACS driven from a radiology, perspective, but from a pathology, it's, we're list driven. And so we're reading off a list, working off lists that are in Epic Beaker so we had some capabilities in the Philips system to send image availability messaging back so that, hey, has this slide been scanned? What is available for this case, etc. And the teams again had to work. Sectra doesn't have that one-for-one capability just yet. So the teams had to work with their API that they do have available to do some callbacks and pull information out of Sectra, generate an HL7 message, get that sent to Beaker, etc. Be able to mirror that image availability slide, let's call it slide level notification availability, so that you can go into the system, you can click on a link, and then that launches the viewer.
So, Chris, let me ask, does digital pathology scanners have something similar to DICOM modality work list, or do they use DICOM modality work list? No. But these scanners that you bought, they are able to acquire DICOM images, right? So how do they get the headers populated with the patient and study information in context?
Yeah, and I can hand off the mic if someone
Okay.
else wants to
Yeah, let's
well,
hear, Heather, do you have the answer on that?
Godwin would be great
Or
for the
Godwin? Yeah.
unifier.
I mean, we
Yeah,
only have
right.
so
Yes,
much at a
I
high
know.
level. I'm curious.
Yeah. So high level, we enrich our data a lot because we are planning for the future here at Stanford, right? And so we're planning for AI integrations, and we do have, like Nikki has mentioned and my team has mentioned, right, that we do have a lot of smart people here at Stanford. So there are container IDs which house the case number, which comes from your list, and that is handled within the barcode on the labels. And so the scanners will put that information into DICOM fields for you. You do have to work with them to configure those things, and then you can use a unifier like we have. We have a great one from DICOM-Sys. They're great partners. We've talked about how we built stuff with them on their podcasts also. And so we have worked with them in order to pull HL7 data into all of the DICOM fields to enrich the data and make sure that we have full fidelity data within our system, which will put us in a better space moving forward.
Interesting. Well, that's probably enough to do a whole show about, the diving into how all that works. But it seems to me like there's some room for improvement in the industry as a whole with standardizing these workflows in digital pathology to get closer to like what we have in radiology, where if you're a CT scanner and you can't do modality work lists, you're not going to make any sales. But it seems like with digital pathology, there's still a lot of custom work that's needed to do, the information transfer. So that's interesting. Heather, why don't you tell me a little bit about the migration? Because, with digital pathology, maybe you can tell me how much larger are these images compared to, let's say, a single view chest X-ray compared to average digital pathology study. Do you have any way for me to grasp exactly how much bigger they are?
Absolutely. And I'll actually say a few words on this and then hand it off to Godwin because he definitely is very, very well versed in that compared to me. We haven't started our data migration here at Stanford. The reason we haven't started our data migration is one, we've got over 4 petabytes of data to move, and two, it is in a proprietary format. And to your comment earlier, Luke, right? We have a lot of standardization that we have to do as an industry with pathology. And there are a lot of people out there that are doing great work on this. And so we need to work with them in order to standardize that data going from the proprietary format to the DICOM format that we would like to go to. Or if there's a better format out there that evolves over the next year or two. But as to the size and how much the data is shaped, I'll let Godwin talk on that because that's some interesting things too.
Thank
Godwin,
you.
let's start with just, one digital pathology study compared to a radiology study. Put that into perspective for us. What's the size difference?
That's a very good questions for listener out there. So first of all, we take pride at Stanford that we normalize every single study that pass through our DICOM unifier router. That's not just pathology, radiology, any other ologies. So in the radiology world, you see one chest X-ray that's about 10 megabyte, maybe to 20, up to 30 for DR. One single DICOM whole slide image can go up to 9 gigabyte, one single slide. And a case in Stanford, a case can have minimum one slide or can be up to 100 slide, depends on how doctors want to see whether it's research or not. So you see that a case like we have 4 petabyte, and that ties back to a lot of the infrastructure that we build. That you have to consider cache storage versus retrieval from long-term storage, and the speed and all that infrastructure that behind that has to consider. So in radiology, you can use a zero foot plane viewer to view X-ray or CT. In CT MR, maybe one single MR case or exam We have functional MRI that can be as much as 100,000 images in one case, and that's probably 945 gigabyte total in one MR case. So you can think of one single slide, microscopy slide from pathology outweigh the entire functional MRI case, 100,000 images. So the
Yeah.
volume is a lot. And talking about migration, you have to look for that information. So that's why we're very proud that we do standardizations, normalize every single files, tags. We spend a lot of time discussing with our pathologists, our vendors, to work on every single DICOM tag, trying to find meaningful DICOM tag that can benefit us now and even for the future. When we talk about AI, you have to go through all that information. And then the informations, the pixel data, those are all you think about compression. Radiology, you talk about JPEG 2000 as nano standard. You have other JPEG compressions that is out there. For the DICOM whole slide images, you have a different JPEG compression as well. So those compression, right now we have the iSyntax. You want to transfer that from proprietary iSyntax to convert to DICOM view SI, that you need to consider different pixel value, pixel data point compressions. And there's algorithm mathematics out there that we are trying to figure out and trying to test with other migration vendor.
Yeah.
Interesting journey.
That's you mentioned to be proud of it. I really respect all that, because this is so much more beyond just doing a file copy from one storage device to another. You're talking about, first of all, the compression, being able to decompress and recompress and all of that. And it's not so easy when you've got compression algorithms that are not modern or standardized. Then DICOM, converting everything to DICOM, is another thing that positions you guys well for a lot of amazing things in the future. So yeah, having to process all that, it's going to be a tall task, but I think it'll be worth it in the end once you get everything standardized and properly formatted to the modern DICOM-based formats and everything. That's great. So you haven't really done the migration yet, but you're live on the system. So new stuff that's going on is going into the new system. How has it been during this stabilization period? People are getting used to the new system. Godwin, maybe you could talk a little bit more about the support processes you have in place. Have you done some things to help these clinicians during this transition period?
Yes. So before going to that, I really need to give kudos to my team, is that we spend a lot of time prepping for that, expecting for that, because it's a new transition for pathologists moving from one platform to a different platform. So we work with our training team, doing a lot of training sessions, recording sessions. We create numerous knowledge-based articles, teach them from how to launch from Epic Beaker and how does the workflow, how does that work with the new viewer, how to launch that. And that was just purely a preparation work. And during the cutover, is really all hands on deck. We do have a lot of teammates that are from upstate. They had to fly in to be there with us, almost 24/7 coverage, almost. We do have multiple ship people covering from literally 24/7, trying to round every single locations. For people who are not familiar with Stanford, we have hospital site. We also have school medicine site. So they round both hospital site and go to the university site. Some doctors there, offices there. So they constantly coming back and forth to check on how doctors experience with the user or experience with applications. If there's a problem, we have a command center or we have a call center that people are on there all the time, and doctors fully aware during the support go live period. They can dial in that number right away. Someone will always answer them, give them help. If we cannot solve on the call, we have someone quickly run over to their office, show them what to do, and trying to gather all the information. So It was very nice. We do also have vendors who were on site, vendor including the sector people, also the scanner vendors, they also on site. So it's a full force trying to support this go live, and really we couldn't do this without all the vendors' help.
That's great, and a lot of foresight there to prepare for what you know is coming. Which is a lot of questions. There's going to be issues. Getting ahead of it sounds like you really did that and planned for it and put yourself in a position to be successful with it. So um, yeah, that's great. We're kind of coming up on time here for what we like to record these at, but I would like to get maybe the top lessons learned from this project. Let's try to limit it maybe to just two of the top lessons learned here. Um, Heather, maybe I'll start with you. Does something come to mind in terms of something you would have done differently the way you guys approach this project?
I think we all will have to admit that we took on a little bit of a big piece of the pie with this project. We replaced our viewer, we replaced our scanners, we built infrastructure to put us into the future. I think that would have been our biggest lessons learned, right? Is that yes, you can do a lot. Maybe chunking it down into phases would have been a little bit better. We were on a bit of a time crunch, so we needed to make sure that we got a lot of this done by the end of the year last year. Um, and so we put a lot in, and our stabilization period, just to expand on what Godwin said, right, is for the past couple months we've been in a stabilization period. We still have a couple of analysts that go on site and help with scanner items. We brought a second set of scanners on live just after the new year. We've been working through issues with those with the vendor, so it's definitely been a lot. Nikki, you want to add another one that you think we probably could have improved on a little bit?
I actually want to add a positive lessons learned, because I think that one of the things that's really important, and I know this has been said before in other arenas, but we had a really diverse team of people that were part of this project that included a lot of faculty members and opinions from the pathology operations team. We didn't understand their workflow, right? And I think for people who are going to be coming into this as a newology for them to work in, digital pathology, take out the digital. Pathology is completely different than imaging in radiology. And they were fantastic. Like, I don't think we could have made this happen without the operations folks, the pathologists. Everybody was gracious and allowed us to look over their shoulder and understand how they do their work in a way that helped us help build them the right system. And I think that if one of the things that is a good takeaway is make sure you bring in all the voices, because otherwise you don't want to be like just throwing something at the wall like, hey, here's some new technology for you. Good luck. Right. So I think that was something we did well at Stanford.
Yeah. Well, it's really been a pleasure of mine to have you all on and to learn from your experiences, and hopefully others share the same opinion. But I know who to talk to whenever some sort of initiative comes up in the future for digital pathology. You guys have established yourselves as, the experts in this area and innovators. So really appreciate that myself as a professional and just representing the community of imaging informatics professionals. It's really been encouraging to see all the work that you've done and inspirational to us. So thank you so much for taking the time to meet with me today, and want to wish you the best of luck as you work on the rest of this migration and finishing this off. So thanks again, and wish you all the best.
Thank you,
Well,
Luke.
thanks for having us,
Excellent.
Luke. We
Thanks for luck.
appreciate you.
Thank you.
Okay, thanks everyone.
Take care.